I hope to understand hear me. And then you can see my screen. As now is controlled. Right, so good morning to all of you. Not all of you, but I can see some of you here. I was waiting, and I think now enough waiting, and we'll start today's topic. Right. Okay. Now let's remind ourselves what we did last. What we did last. Did we? Remind. That was up there. Okay. Correlation and we discussed about correlation. So, one relation. There's a relationship there to play. Okay, so we say whether the hypothesis we discussed whether the relevant hypotheses are supported or not. Isn't it? So we going to explain. Right. So those are things we discussed, and we had a significant discussion on that. Both correlation. So let me again remind you where we are. Like always, we have to see where we are. Then what's good? We know where to go and what we need to do to go there. Is it? So where we are now? What are the topics, main topics that we have covered? We have covered the basics of data, how to open data, how to create a base case data, how to label variables, how to provide value labels for different options in the variables like gender, male, female, right? You knew how to do that, and even how to make certain computations we know each day, right? We have that type. Right. Now, what we are going to do is we are going to extend, right, our discussion. These an extend our discussion to analysis. What kind of analysis? What's the first type of analysis that we did? Descriptive analysis. We perform all kinds of descriptive analysis based on the type of the variable, whether it's a categorical variable or a continuous variable. We selected what the type of analysis that we perform. So if it had been a categorical variable, what would the analysis be? We perform a frequency analysis. But on the other hand, if the analysis is what? A continuous variable, then what kind of analysis we perform? Methods of central tendency, dispersion, distribution, and location. We discussed how to do that, and we analyzed and we understood how to perform those things as well. So a comprehensive discussion we had done. Then did we stop from there? No. Fortunately, unfortunately, we discussed more analysis. We did portion. Is it? What was the analysis we discussed? Correlation analysis. So last week we discussed and we finished the correlation analysis. And also I go through how to go ahead with correlation analysis and even test hypothesis. Isn't it? So what's a hypothesis? A hypothesis is a testable assumption. The assumption might be okay, there's a relationship between two variables. We either reject that or we support. Right? Can you remember? Okay. So those are the analysis we discussed so far. And today I would like you to understand more analysis. Indeed. Right. For that, let's go to your element as well as to the next part of the things. So let me take you to the element. You are 18A 60DWE. So 60D, this you. Am I correct? 60DW 18A.
Yeah, 16A WE, 18A EXP. Right. Okay. So let's go to the next analysis. Now we have discussed the introduction to Stata. That's where we discussed how to create data sets, how to import data from Excel to Stata. So those kind of things we discussed. Then descriptive analysis we discussed, and we did a small further analysis in Stata. And then we came into correlation analysis. This year we discussed about correlation analysis, and we also did a small additional data set. We took a data set and we discussed it as well. And today we shall go to the regression analysis. So students that are under week number 6 will see that there is part one that's named as data session 4 regression analysis. Can you please download it and open it? Today I'm going to discuss that. And we are going to discuss about regression analysis. Right. And I'll teach you in and out how to do a regression analysis, how to interpret the results, and finally coming to conclusion. Right. So today is going to be a very important session. Indeed, all sessions are important. Like part of the body, all parts are important. Without the hand, without the head, without the organs, you can function properly. But some organs are vital, like the heart and the brain. So this is like brain regression. So I would like to ask you to take your full attention here. So please download these files, all the files together. So data session 4 salary, and then data session 4 survey for ED5, and then data session for expected salary. Yes, just download it. And for the time being, I'll be using data session 4 regression analysis and data session 4 salary. So at the beginning, so at least download the two files, the PowerPoint file and the data file that says data session 4 salary. And I will go to download it. Take your time, please download and open the regression file. So I'm going to open the regression file. I have already downloaded the okay, here regression is there. So I'm going to open the regression file. The regression PowerPoint file which says data session 4 regression analysis. Please open that. Right. Now let me remind you the purpose of certain analysis. Why you are doing certain analysis. What was the purpose of doing a descriptive analysis? Why did we do a descriptive analysis? So you told us we did that. No, it's not a way of explanation. Why did we do a descriptive analysis? No, there was a purpose. Behind everything that we do, there should be a purpose. Why we are doing this degree, there is a purpose. Right? Get 4 things. Knowledge, skills, and the attitude and the mindset. As I always preach. Right? That's why you do this degree. Why? So you could be a fully fledged professional, a graduate professional. So that's why you are doing this. Likewise, behind each and every analysis, there is a purpose. So up to now we have discussed 2 important analyses. There is descriptive analysis and the correlation analysis. So if I ask you, what's the purpose of doing descriptive analysis? What's the purpose? Describe some. Describe. Hello. Descriptive analysis. Describe some. You will summarize and you will try to describe. So that's the main purpose of descriptive analysis. Then what's the purpose of doing a correlation? Why did we do a correlation? What's the main purpose of doing correlation? See the relation. is the relationship or the association between two variables. I was telling, descriptive analysis, you take one variable and you try to analyze that. So we call it what? A univariate, bivariate, or multivariate. Descriptive analysis is what? A univariate, bivariate, or a multivariate. It's a univariate. Uni means one. You take one variable and you describe. For example, you take the age variable and you describe it, isn't it? You see what's the mean value, what's the median value, what's the interquartile range. So by taking those descriptive statistics, you try to describe one variable at a time. So that's why we call it a univariate analysis. Univariate. Univariate means you take one variable and you describe. Then, what's the purpose of doing a correlation analysis? A correlation to see the association between two variables. So if you take two variables, we call it what? Bivariate. Bivariate, because bi means you take two bivariate. Univariate one variable and you describe that. Bivariate analysis, you take two variables. You take two variables and you look at the association. Why we call a bicycle bicycle? Because it has two wheels. Two wheels. Why we call biannual biannual? Because we have to do two things annually. Biannual. Right? So likewise, you can see these are analyses that we perform on a univariate basis, bivariate basis. When it comes to regression analysis, you will see there is a bivariate version as well as a multivariate version. So I'll explain those things clearly. Don't watch. But first of all, we need to understand why we perform regression analysis. Descriptive analysis, I told to describe sample. But correlation analysis, I told to see the association between or the relationship between two variables. Then why do we perform regression analysis? What's the purpose of performing regression analysis? That's what we have to understand. Why do we perform? So when it comes to regression analysis, we perform regression analysis for two reasons. Two reasons we could perform regression analysis. One, we could take down, okay, please take down purposes of performing a regression analysis. Purposes, please take down purposes of performing a regression analysis. Purposes of performing a regression analysis. Purposes, plural, purposes of performing a regression. Number one, first reason. Number one, for prediction. For prediction. For prediction. For prediction. Number two. Number two. Number two. To check the impact. To check the impact. To check the impact. Check the impact. Check the impact. Of independent variables. The independent variables. The independent variable. On the dependent variable. On the dependent variable. Right. To check the impact of independent variables on the dependent variable. And number one is for prediction. So you will understand what I'm saying. You will see how I did that as well. Right. So here we are discussing about linear regression. There are other types of regression analysis as well. We are trying to discuss about linear regression, which we call the OLS regression, ordered least squares regression. What do we mean by that? I think we could remember under correlation analysis, we used a graph called a scatter graph or a dot diagram. or a scatter diagram. Scatter diagram or dot diagram. And we looked at the relationship between two variables. Let's say, for example, we looked at age and life satisfaction. Age and life satisfaction. Age and stress. So those are two variables. Now what we are trying to do is, we are trying to predict the life of best fit. What does it mean? So let me show you. So since I'm a little bit unable to use the board because of online students, I'll use this one again. See what's this? Let me take a pen. Good. You have seen it. Is a discard करला अभी okay, let's come back. And ideas if there are there any part. Please take a blank slide where you can. Oh, it's visible. Right. Now let's try to see what is revision this is all about once for all. So as I told you, it is character diagram. We have how many axes? We have two axes. What are the two axes? X and Y. Right. There's X axis and Y axis. X is what? X axis we denote to what? We denote X axis to what? Independent of the dependent. Independent. This is the independent. And then the Y axis is what? The dependent variable. Right. Let's take an example. Let's take an example here company. For last, let's say 24 months or so, you are going to take the advertising expenditure and the sales revenue. What's the independent variable? What's the independent variable? Advertising expenditure and the sales revenue. What's the independent variable? The expenditure. We discussed that. Advertising expenditure. Dependent variable is the sales revenue. So what we do is, now for last 24 months or 36 months, we are going to draw the relationship between these, let's say, advertising expenditure and sales revenue growth. The E dot represents the corresponding advertising revenue and the corresponding advertising expenditure and the corresponding sales revenue. Right? So now what we are trying to do in a regression analysis, carefully listen to this. Right? In a regression analysis, what we are trying to do in an OLS regression analysis, we are trying to fit a line that best fits these dots. We are trying to fit a line that best fits these dots. But can you fit all dots in one straight line? You can't. But you are trying to do, right, the best. So that's what we call the best fit line. The line OLS is that already least squares. It takes the least distance and close this line. That goes across most of these dots. Right? So this is what we call the regression line. This is called what we call the regression line. The line of besting. Right? You have to just understand. So you know in your O levels, you understood, right? The equation of a straight line. Your O levels, right? You understood the equation of a straight line. What's that? Y equals what? A plus EX. Can you hear me? A plus EX. This is the equation of a straight line. You study in your O levels. They are not a motor. Please check coming from the motor thing. 20 years. 20 years, I think some people here might be right. Padagan outside. Here. More than that. Okay. In your O levels, you study the equation of straight line. What's that? Y equals A plus BX. Right. Now you know what's Y and what's X. What's Y? The dependent variable. Right? Here what's that? The sales revenue. Y is the sales revenue. X is what? The advertising expense. Then what is A and B? A plus BX. What is A and B? A is known as what? The intercept. A is the intercept. In single language, you don't need to know that. So again, in single language, you call it the intercept. What? Antaplan. But you don't know. In Tamil language, it's also called the name that I don't know. That's it. You don't need to know that. Right? Single Tamil, only English version is enough. Intercept. Intercept is where when x is 0, what's the y value? That's this. That's this A. When x is 0, what's the y value? When x is 0, what's the y value? Let me take another example. Income and rice consumption. Income and rice consumption. Let's take, I took 4,000 people in Sri Lanka. I took the income levels and the rice consumption levels. And I give this catapult. Can I do that? Yes. Then I will try to now fit a line. I'll try to fit a line that represents these dots. Most. Now what's X? What's the independent variable? Income. What's the dependent variable? Price consumption. Likewise, we have to first understand what's the independent and the dependent variable. Okay, let's go with the income and rice consumption. Now, what the intercept means here? When x is 0, what's the y value? If you apply that to our example on income and rice consumption, what it means is when income is 0, what's the rice consumption? Right? When income is 0, is there rice consumption? When income is 0, is there rice consumption? Yes. Beggars, former politicians, thieves, looters, they have 0 income, but still they consume rice. Beggars, best example, and some former politicians are very good example. There are some politicians, sons and daughters, who don't do any job, but they consume rice. Not only rice, they consume everything in this world. And some of their cats are worth of 500,000. But what they are doing? Nothing. These are the flexible. Can you do it? So likewise, you can see, even though the income is zero, still guys, that's called what? Intercept. So when income is zero, you can see it's here. When income X is zero, still there is what? Why? That's rice consumption. Do you understand now what's intercept? Intercept is that when the X variable is zero, what's the Y variable? So when X is zero, this whole thing becomes zero. Dx becomes zero. X zero na Dx is zero. Because the Y equals to not here. Y becomes equal to A. Y is equal to. So that's called intercept. Is it clear? These are taught to you in all levels. And now we are in a degree program, and I'm really sorry to somehow the other one now again. So I'm going to think that the Zinga develing India right. So this is what intercept means. So what's B? A is the intercept. A is the intercept. 5 plus A plus BX can A intercept here. Then what's B? B is what? The slope. B is the slope. B is the B. The slope. What's the slope? B is the slope. B is the slope, which is also known as the coefficient. Is also known as the coefficient. So I suggest you write these things if you cannot remember. These are very basic stuff, but again, it's my duty to remind you. I know because you might have forgotten this. So here, let me summarize what I told. I told that we can draw a scatter plot diagram between independent and dependent variables. Right? I can draw a scatter plot diagram between independent and dependent variables. Here I took the example, I took several examples, but finally I took the rice consumption, income, and the rice consumption of individuals. So I take 1,000 people and I draw a scatter plot diagram. Then I try to draw a line of best fit that fits most of those dots. Each dot represents an individual cost as well as rice consumption. Then I try to draw a line of best fit, and that line is called the regression line. It's a straight line. But it's not straight, it's a straight line. So you know in your O levels and your other studies, you might have studied that the straight line, the equation of straight line is given as what? Y equals A plus BX. That's the next thing I taught. Y equals A plus BX. Then I taught you what's A. Now in this example, when X is 0, what's the Y value? When X is 0, what's the Y value? When income is 0, what's the rice consumption? Still people eat, indeed. They bake, they rob, and they eat without having 0 income. Without having 0 income, they go there rob. Beggars there, they don't have any income, but they beg and they get money and they eat. Home politicians, the current one seems okay, at least, but now some disturbing evidences are coming directly from some close areas like Mount Lanka. So, but however, we'll see in later. We cannot come into those conclusions. So that's what we have to say. When income is 0, what's the consumption? That's what is called the intercept. Then A plus BX. The B is what? B is called the slope. This is also known as the coefficient. The coefficient. Slope or the coefficient. So what it says is, if we know A and B, we can predict what's Y. Right? If you know these things, now if you have the X value, and if you know A, the intercept and the slope, we can predict the Y. If we know the alpha value, the A, and if we know that means the intercept, and if you know the slope, and if you know what's the income, then we can predict the consumption. So that's what we call prediction. You know the alpha, if you know the slope, and if you know the income level, you can predict what? The consumption. You'll be able to predict the consumption. So that's the fascinating fact of prediction. And we today itself will do a prediction. You do your first prediction, maybe we'll do it together. Right. Now this is what was stored in your O levels. Footprint level. What I did then? I reminded. But now you are in a degree program, isn't it? Now we don't say y equals a plus bx. We would say something very similar, but again now we say y equals same thing. Y equals what's the large equals that? Alpha plus theta x. Same thing. Now some alpha and beta has come. So same meaning. Alpha is what? The intercept. Beta is what? The slope. Same thing. Alpha plus beta x. Right. Is this clear? This is the first thing that you have to understand. Alpha plus beta x. A plus bx and maybe alpha plus beta x. Is it clear? Now the next question is, can we predict something? Okay, right. Oh, let's come to that question a little bit later. Right. Now my question is this. Is rice consumption only dependent on income? Rice consumption is dependent on income? No. The demand of a product is dependent on several things. Price, income, customer preference. Likewise, there are different things. Under your economics, you were there studying, isn't it? So here I have taken only income. But you can take some other predictors as well. Before coming to that, you have to understand here how many variables are there. If I take y plus alpha plus beta x, how many variables are there? Only two variables. One independent variable and one dependent. Can you see that? Here you have only one independent variable and one dependent variable. One independent variable and one dependent variable. In that case, this is called a bivariate regression. Why is it called a bivariate regression? Because it has only two variables. This is called bivariate regression. Bivariate regression. You can just term it as bivariate regression. This is called bivariate regression. Why we call a bicycle because it has two wheels. This is called a bivariate regression. Bivariate regression. Another slide. That's called bivariate regression. So let me draw again a bivariate regression. Bivariate regression. Y equals alpha plus beta x. These are bivariate function. Only one independent variable and one dependent variable. Right. Now, can I add more independent variables? Yes, you can add more independent variables. So I would like to include the price. The price. I would like to include the customer preference and some other variables. Here you can see y equals alpha plus, let's say beta 1, x1, beta 2. I can hear some students speaking. Please don't speak while being in the class. It's disturbing me as well as others. But kindly maintain the discipline in the class. So beta 2, x2. So you can see it here. I have now how many independent variables? I have how many independent variables? I have two independent variables, x1 and x2. It could be income and it could be price of rice. x1 and x2. So earlier one, I took only one independent variable, x. But now I have taken two independent variables. I can take many. The first one is known as a bivariate regression. Why? Because it has only two variables. The second one is known as what? A multiple regression or multivariate regression. Multiple regression or a multivariate regression because it has more than two variables. If you have more than two variables, you call it a multiple or multivariate regression. Right? Multiple or multivariate regression. Okay. So what we are trying to do is now you are going to put more predictors, more independent variables, and try to predict the dependent variables. Now maybe it's income and maybe the price of rice. I can put an x3 as well. Beta 2 x3 maybe the customer preference, customer taste. So income, some people who are having income might think of not eating rice. They might be thinking of eating pizza. Some other food they prefer. Some people like to eat garbage, so it's including myself sometimes. So that's x1 and x2. In this case, you have more than one independent variable. Call it what then? You call it what then? Multiple or multivariate regression. Right? Variable देखा समझिए. Independent variable, dependent variable, can be bivariate regression. Bivariate. Two variables. If there is more than two variables, right? More than one independent variable, there will be always one dependent variable. In that case, we call this what? A multivariate or a multiple regression. So what we are trying to do? We are trying to predict the rice consumption by putting more and more independent variables. But my question is, can we predict something 100%? Let's say, for example, x1 was the income and x2 was the price. Can we predict 100% the income, the price consumption? You can't. So therefore, what you have to also understand is always there will be an error term. Because there are certain variables that we might not have taken to this point. Here I have taken only two independent variables. There could be some other variables like customer taste, which I did not take. So that loads into the error term. And this particular term is known as error. It's not pronounced as E, it's pronounced as what? Epsilon. Well, epsilon maybe. epsilon, epsilon. Don't worry if you forget that, that's no problem, because at the exam I won't come to you and ask you, okay, pronounce it. Slow the Gilbong hand, never exam again. But that's known as epsilon. Right? So these there, you also will have an error because you cannot predict 100% certain things. Predictions are prediction. So this is the basic in regression analysis, which was taught to you in your ordinary levels and in your first year statistics or second year statistics. When did you have the statistics? In first year or second year? First year or second year? So we did not hear what's that term statistics till now. Is that no? Well, that's the first year. So first year that lecturer should have told you. Unfortunately, the lecture is not at the moment in this meeting. Right? The Australian lecturer in hand of meeting. He over there. Just joking. Okay. So what you have to understand is there is an independent variable and there could be a dependent variable. In that case, if you have one independent variable and dependent variable, it's known as what? The bivariate regression. If you have more than one independent variables, in this case, in the second case, there are two independent variables, then it's a multiple regression or a multivariate regression. Is that clear? It's not different, right? So you have to understand these things. And the next thing what I propose, if you cannot predict, since you cannot predict things 100% accurately, there will be an error. These predictions are done by using past data. Even AI could make mistakes, right? But yeah, you are using ChatGPT, generative. Every second, I'm using that for my tasks. Not to coach assignments in each assignment, but for other purposes. Numerous purposes are using that. I don't know. I'm really fortunate to use that in my lifetime. You should be very fortunate to use that in your lifetime as well. It was not there a couple of years back. Increases the productivity like 100x. You know how to use it. Right? AI, how AI works? By looking at past data. Machine learning is what it does. It learns and then it provides the answer. So if you give wrong data, it will provide wrong answer. Simply that's the problem there. Here also same thing. You are doing this regression based on past data, past revenue, past but advertising expense. So if you give wrong data, it will give wrong prediction. Always there will be an error. Is that clear? So I have jotted down these things as well. So I have put this in the original slideshow. Now let me go there. So I have written down these things. So I differentiated between simple and multiple regression models. So then I showed you what's the simple regression. In a simple regression, you can see here what's beta 0. Beta 0 is like alpha, it's the intercept. Then beta x is the independent variable, and E is what? What called means epsilon is what they write. So here you can see this is simple regression. Why? There's only one independent variable and a dependent variable. But now here, look at this. This one. Now there are several independent variables. Can you see that? X1, X2, and it can be even X3. Any more you can have. More than one independent variable. In that case, what we call it? the multiple or the multivariate regression analysis. Right? Is this clear? We'll do it again. I'll show you how to create these things, how to interpret these things, everything I'm going to teach you. Right? From rock bottom. So I'm actually taking you from all levels. I could have directly started with regression analysis with the degree level. But if I'm going to do that, I'm not considerate. I have to be considerate. I have to remind. So, to be considerate and conscious, as well as to help my good students, that's my attitude. Right. Okay. Now, I think theory. Now, theory is, let's now see how to use data and how to do a regression analysis and how to interpret the result. Theory. Right? O-level again, degree part 1. But now you are degree part 3. Right? And you are more advanced students. So now let's go to the advanced analytics. For this, I'm going to use this example, which is called the programmer salary survey. Here, what we have done is, in an organization, there are 20, let's say there are 20 programmers. Right? 20 computer programmers are there, right? They are coders. So these computer programmers, data is given in the next slide. Are there 20? Yes. There are 2 columns. In the 2 columns, you have what? You have 3 variables. Although there are 6, it's a repetition. So the 20 is given in this way, right? So you can see what are the variables given. You can see there are 3 variables available. What are 3 variables? Experience, salary, experience, score, and the salary. Can you see that? You can see the experience. Okay. Experience, score, and salary. Can you see that? What it says is simply that the salary of a computer programmer depends on 2 things. One, the experience. The other one, score means the marks that person had got for the aptitude test. The other hand, it represents what? The knowledge. So, in other words, what it says is the knowledge and experience predicts the salary. Again, let me repeat what I told. Here you can see how many variables? 3 variables. Salary is there. Then the experience of a computer program is there. And the score means the marks that person got for the aptitude test. Right? Each of them did an aptitude test. And they got marks. And in American terminology, we call them scores, not marks. So it's the marks that they got, the score is there from out of 100. So you can see the first person got 78 marks for the aptitude test. So the aptitude test represents what? The knowledge. Experience represents the experience. So what it virtually says is the experience and the knowledge predicts what? Is that clear? That's what simply it says. So this data is given for how many computer programmers? 20 computer programs. Right. Now, having told that, tell me how many independent variables are there? First of all, what's the dependent variable? Salary. Salary depends on 2 things. What are 2 things? Experience and the marks, the score. So in that case, how many independent variables are there? What are the independent variables? Experience and marks. Experience represents experience, marks represents the knowledge. Is that clear? First of all, when an example is given, try to understand what's there. So I have given a description, but I came directly to this. So the description, if you go to the earlier slide, the description is there. So it says a software firm collected data from 20 computer programmers. A suggestion was made that regression analysis could be used to determine if salary was related to the years of experience and the marks, the score or the marks that a firm's programmers aptitude test. They are going to aptitude test and check it. So that's the knowledge. The years of experience score the marks of the aptitude test and the corresponding annual salary in $1,000 for a sample of 20 programmers are given in the next slide. So that's what I explained to you. Is it clear? Now what we are trying to do is we are trying to do a regression analysis using this data. Right? An OLS regression analysis. Right? And you will understand we are going to do several things out of it. Mainly two things. What's the purpose of doing a regression analysis? Two things. Number one, to see the significance or the impact of it. Number two, to do the prediction. We will do both. I'll show you how to do that step by step. Okay? Shall we do it together? Okay. The first step is what? Now the data is in data, we need what? A data set, not a PowerPoint data set. But we need a data set. It's already given to you. That's where you can download it from the LMS. And please open that LMS file. Let's go and open that. And I'll tell you step by step how to do a regression analysis. And particularly how to interpret the result. You don't need to know about the, did I now, when I talked to the correlation analysis, did I need to the formula? Formula here? Do I need to teach that formula? No. You have, I think, learned that in your first step. We don't need to know the formula. We need to know how to do it using data. Once the output is there, the rest is interpretation. So that's why I'm going to now teach you how to do the regression analysis. But for that, first of all, you need the data file, and I have given you the data file in the LMS. Download it and open it. Shall we do that together? Okay, so let's do that. So first of all, go to your LMS and download this file, which is in week number 6, if you have not already done so. Data session 4, 7. Can you please download it? And once you download it, open. Now we're going to open. So I download it and I'm opening it. This is data file, so I can just double click and open it because data is installed in my picture. You have to open data and then open it. Okay. Let's allow some time for that. Because now it's action time. Here time is over, now action time. Can you open? Open the other. Good. Follow. Follow the computer here. Follow the next oh my God. Online students, were you able to open the particular data set? Online students. We have 21. WE21. EX3. EX30. SK. So you have to put your proper name, right? You have to put your proper name. Number 75. 14.
Yes, sir.
Angelina.
Open it.
Are you able to open it?
Trying to opening, sir.
Open it.
Trying to opening.
Okay, good. Very good. Melanie,
Yes, sir. Open, sir.
you open it?
Yes, sir.
Very good. I'm just checking. Right. Okay, extremely good. So once you open a file, what's the best practice? Give the data. Data page there. You can see there's an indication the file is open. Why? Because why? You can see it's over here. The variables are appearing here. Right? Where in method one it's all about now. You can see here. It's there. So how many variables are there? Score, experience, score, salary, membership, and membership month. Some additional variables are also there, which I'll use later. So you can see there are 5 variables. So the best practice is once you open a data set, import, open, or whatever, do what? View the data. How can you view the data? What's the command we use? You can use the browse command. You can go to this command, window here. Right, I'm going to go to the command window there, and I'm going to type browse. BROWSE. To see the content. What are there? If you want to edit the content, you will use what? The edit command. So browse, hit enter. So now it will open the data. Yes, the data is there. You can see here. These are the variables: experience, score, salary, and it's given for 20 computer programs. Perfect. Task achieved. Once you import or once you open a file, please check the content. Sometimes some nasty things happen and you might not get your correct data. Who knows? Better to protect it. Right? Okay. Now let's see how to perform an OLS regression analysis. So please take down a small topic. Performing an OLS regression analysis. Performing an OLS regression analysis. Performing an OLS regression analysis using an OLS, order least square, an OLS regression analysis using data. An OLS regression analysis using data. Using data. We'll see how to do that step by step. It's very simple. Some elements we have. There's even simpler method. I'll teach you later. Just you can type certain things, but again, I'll take you to the menus. How to do that? What to do is while you are in data. So this is the data interface. Now go to statistics. Can you see that? I'm going to expand it. I'm going to go to statistics. Then you have one steps. Statistics here, put it left. Write down statistics and put a small arrow. And then go to second option. Linear models and related. Linear models and related. Linear models and related. And go to linear regression. Because we are going to go linear regression. OLS regression is linear regression. Linear regression. Linear regression. Is it okay? Shall I click that? Right there. Linear regression. So click on that linear regression. Then comes a dialog box, which asks some information. In this dialog box, the first thing what it asks is what's the dependent variable? What's the dependent variable? How to go on? What are the dependent variables? Go and see the list. What's the dependent variable? Salary. You were telling that salary depends on two things, independent variables. So what are the two independent variables?
two independent variables are experience and the score. Experience is the experience of the computer programmers. Score is the aptitude marks that the person got for the aptitude test. So that's the score. Terminology in America we use a score, partial score, event score and other things. In Sri Lanka as well as in UK we use the marks. Right. Okay. The score. That's all. For salary you choose here. Experience score you choose here. Now what you need to do is scroll it down, and in the dialog box you will see okay. I'm going to make it smaller. Now this is the dialog box. You need not choose anything else. Just choose the independent and the dependent variables, right? And then you can see here, press OK. Shall I press OK? It's OK. That's not what you're meeting. Just select this and press OK. Shall I press OK? Yes, it's OK to press OK. OK, press current on that. OK to press OK. So I will press OK. Then comes a nice regression output, which I'll be explaining to you one by one. Right, not all are important, but I'm going to take the important parts and I'm going to explain. Right. Perfect time. Regression. The first thing that I would like to explain is something called what's this R square. Can you see? There's something here. This is the regression of. Here you can see something is here called R square. So why not to write down R square, R to the power 2. R square, R to the power 2. R square here. No, yeah, square here. The real way to write that is the correct way to write it is R square. R to the power 2. Yeah, the idea can be just square to the idea. But the real way to write it R to the power of 2. 2 is superscript. To the power of 2. So it says usually we express this value not as a fraction but as a percentage. So if we convert this 0.8342 as a percentage, what's the value? Take the percentage and convert again. 83.42. According to this item, R square is how much? Equal 83.42%. 83.42%. You have to convert this to a percentage. I'll tell you why. You will understand. 83.42%. You will understand why we express that as percentage. R square is 83.42%. Right? Exactly. 83.42. So what is R square? First of all, R square means the explanatory power of the independent variable. Here, R square represents, R square indicates, R square indicates the explanatory power, R square indicates the explanatory power, the explanatory power of the independent variable. The explanatory power of the independent variable. Here, the the R square value, the R square value, R square value, 83.42%. The R square value, 83.42%, 42% indicates that, indicates that, indicates that, indicates that the two selected, the two selected, the two selected, the two selected independent variables, the two selected independent variables within brackets, experience and marks, within brackets, experience and marks, close brackets. Clear the problem. Explain marks. Explain 83.42%. 83.42% of the variation of the variation of the variation of the variation of the salary rate of the variation of the salary rate of the variation of the salary rate. Did you understand? So 83.4, almost 83% of the variation of the dependent variable. What's the dependent variable? Salary is explained by these two independent variables. That means almost 17% of the variation of salary variable is explained by some other variables that has not been considered under this equation. Full stop, right? And say this also means that 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 the remaining 17%, the remaining 17%, the remaining 17% of variation of variation of variation of the salary variable of the salary variable of the salary variable of the salary variable is explained other than these two independent variables. And R square, then full stop, other than these two independent variables. Full stop. Other than these two independent variables. Then full stop. Right? And then let's take down. An R square value over 50%. An R square value over 50%. An R square value over 50% is considered to be acceptable. Acceptable. Not good, but acceptable. Higher weight. Paper, higher fit. That means what? The two dependent variables could explain how much? 83.42% of the dependent variables. Yes. Higher weight. Right. Is that clear? The value is going up and up, that means it has more explained power of the independent variable. The good model. Here, what can you say? Is it good or bad? It's good. It's 83.42. I was saying 50% is acceptable, then 83.42 is really nice. So that's the final conclusion. The R square value of this equation, or the R square value, the R square value of this model R square minus this model is good. Is good. Is that clear? So this is about R square. What does R square show? The exponent of the independent variables. The two independent variables explain 83.42% of the dependent variables. That's it. Okay. Right. Okay. Therefore, break the current. Let's say a small break. It's almost 10. By 10:20, please come back and we are going to, I'm going to explain the rest of the output. Then I'll start with what is F test and CT. F test is there, the CT figures, and after that, I'll be coming to the predictor. So we discuss all the important things and even do a prediction today and go ahead. The next week we will discuss about regression assumption. Series. Previous one. Multi-coordinating, heteroscedasticity, likewise then photo formation, likewise there are a lot of things that we have discussed there. So these are still basics, but again I'm going to explain from bottom. Right? And gradually take care. Right. Please have a break and come at 10:20. A. Today. Today. Right. We'll have more break.
It's like, oh, you know, like, right. Okay, let's come back. We were discussing about the regression result. First of all, we discussed what? R-square value. We discussed the R-square value. And we understood R-square value equal to the experimental power of two independent variables. R-square value is the experimental power of the independent variable. So here we express the R-square value as what? A percentage. So the percentage here is what? 83.42%. What does that mean? That the independent variable should explain 83.42% of the dependent variable. So this value highly actually an acceptable level to be 50%, right? So those are the things that we explained related to R square. Now let's go to the next one. Please take down the next explanation that we are going to use on the F test. F test. Please take down number 2. First one was R squared. Number 2, F test. F test. That's the next thing that we are going to discuss. So the F value is how much? You can see the F value is 42.76. Can you see that on the top? Right. Your right hand side it says 42.76. F value is 41.46. And the significance value for the probability significance value is 0.0000. Please note down those two. Please note down those two things. Note down F value equals 42.76. F value equals 42.76. And then the significance value or the probability value, which is just below that, it's 0.000. These two things. These two. The probability value is 0.0000 and the F value is 42.76, right? Please note down those two things. Here, probability value is the significance value. Can you remember I talked about the significance value? Can you remember I talked about the significance value? And the analysis. What is the Rabat? I told the significance value under correlation analysis. I told you that the sig value or the probability value or the p value, all are the same, should be less than what? 0.05. It should be less than 0.05. Now here tell me by looking at the F test, what's the probability value of the F test? 0.0000. There is a value which is very small. Is it less than 0.05? Is it less than 0.05? Indeed, yes. It's even less than 0.01. Is it good? Yes. We were expecting this value to be always less than 0.05. Right? So the conclusion is because the sig value or the p value or the probability value is less than 0.05, we conclude that the overall model is valid. Let's take down. Since the sig value, significance value, is the sig value, within brackets p value, comma probability value, these are some other names, probability value, comma probability value, p value, comma probability value, close brackets, right? Of the F test,
is less than 0.05, is less than 0.05, it is concluded that it is concluded that it is concluded that it is concluded that the overall model, the overall model, the overall model, the overall model is valid, is valid, is valid. Please underline the term overall. Please underline the term overall. Please underline the term overall. Overall. What you have to understand is the overall model is valid. Different. The overall basis, the model is valid. So you have to see this. Now, if it is not valid, then there is a problem. That means the model is not good. What is model? Model treating by one day. The equation. Equation is the what? The equation. Model is equal to the equation. You have already have model equals equation. Equation equal. Regression model equals regression equation. So model you have put equation model equals regression equation. Whether on an overall basis this is valid or not. Is that what we are trying to say? Valid is so it's valid. That's good. Right. Next we are going to come into a very important area. That's where we come into this one. The last table. Look at the last table very carefully. It's a very important table. You can see here, in the last table, you can see here, there is something called cons. Can you see that? Underscore cons. What's that? Underscore cons represents what? So you can take a third topic under, now, first one was R square, the second one was test. Third one, you can say coefficient table. Coefficient table. Coefficient table. Coefficient table. You can say coefficient table. Coefficient table. Coefficient. Right? Under the coefficient table, you have to look at several things. Two things in there. One thing you can see is there something called underscore cons. What's that? That represents the intercept. You can say underscore cons and put an equal sign and call it the intercept. Can you remember in that state, that graph, I drew an intercept and I even called it right? So that's called the intercept. This is the intercept. In data language, underscore cons means the intercept. Whether they have so that's cons. Then you can see these two are what? The independent variables. What are the independent variables? Experience and the mark. Experience and the marks are the two independent variables we have considered. What's the dependent variable? So these now are there. Now we are going to understand a very important thing. So closely look at this. You can see you have the coefficient. Now you have the coefficient source. These are called the coefficient. The coefficient. And you can see also the probability values. P values are given. These are the probability values. So you can see for individual independent variables, experience and scope, the significant levels are given. Right? For individual independent variables, the significance values are given. Then earlier I told about the F test. What was that? I asked you to underline something. What's that? Overall. It says overall whether the model is okay or not. Here now what it says is whether what separate independent variables are significant or not. So those are two different things. Right? Maybe sometimes the overall model is valid, but sometimes some independent variables might not be significant. That's possible. That's why I asked you to put it as what? Overall. Overall, it's valid, but maybe on an individual basis, some variables might not be valid. That's fine. Here now tell me, experience variable, is it significant? Look whether this is less than 0.05. Yes, it is. Because this is less than 0.05. And see whether the coefficient is positive or negative. Is it positive? Yes. What it says is there is a significant positive impact on self. There is what? There is a significant positive impact on self. That's what you have to understand. How about score? Oh, is it significant? Is it less than 0.05? Yes, indeed. It's even less than 0.005. It is less than 0.005. We were expecting less than 0.05. This is even less than 0.05. Even is less than 0.01. So is it significant? Yes, it is. Again, what kind of impact is there? The coefficient has a positive impact. Is that clear? Right? You have to understand this. Right? So you can say this table indicates, in the coefficient table, this table indicates the individual significances. The individual significances. This table indicates the individual significances. This table indicates the individual significances of the independent variable. The individual significances of the independent variable. Individual significances of the independent variable. Full stop. Here in this example, both the experience and the scope, variables are significant. Both the experience and the scope, both are significant. And positive. Can also data and positive. So now we could confirm the hypothesis or not as well. We can develop two hypotheses. For two independent variables, we can have hypotheses as we did for the correlation analysis. What are the hypotheses? The hypothesis are testable assumption. What's the hypothesis for the first variable? H1? Shall we take down? What's the hypothesis for H1? Hypothesis. Hypothesis. You can take them. Hypothesis. Hypotheses are testable assumption. So we can say H1. H1 colon, you can say what? The experience of computer programmers have a significant impact
on their salary. Then H2. What's H2? The aptitude test marks. That's a score. Right. The computer program. These are the two hypotheses that we could count, isn't it? Now, based on the results, are these hypotheses confirmed? These are the testimonials now. So you develop this at the beginning. You develop this at the beginning. Now the question is, write down these two hypotheses. Right? Before you even collect data, right? We are going to develop these two hypotheses. What are the hypotheses? Right? The two hypotheses indicate that independent variable is having an impact on the dependent variable. You can say either positive or negative, that's fine, but again, I would not say site usual. I'll say that the experience has agreed. Right. So you can see much better now, H1 and H2. So the experience of computer programmers has a significant impact on their salary, and the aptitude test marks for of computer programmers have a significant impact on their salary. Right? So these are the hypotheses, these are the assumptions that you make before even you collect the data. Now you have collected 20 programmers data, this one you do even before you do it. Now based on the results, are these hypotheses confirmed or rejected? Confirmed or rejected? Are these two hypotheses confirmed or rejected? Based on the results? The මේකට අපන්නේ test එක කරන්නත් කලින්. Hypotheses are made before this, you make the assumption before the test. Right? Now when you go to a doctor, right? The doctor makes a hypothesis first of all. What's the hypothesis? This person is not well because of this particular sickness or ailment. Maybe the doctor might see a person goes to a doctor having fever continuously and pain and red spots here and there. Then what does the doctor hypothesize? This person probably might have, but then it would be again. That's how doctors make happen. Then what afterwards? Does the doctor run a regression analysis? Does the doctor regression analysis do? Or can't know state egg? Let's take state egg. Let's talk state egg. Here. Let's don't bring state. The doctor prescribes a test. What's that called? What's the test? The platelet. And give that prescription and the baby test is given. And then you go to a lab and get the test result and bring that test result to the doctor. The doctor looks at the test result and says, what? Yes, my hypothesis is confirmed. My hypothesis is confirmed. Or else maybe for the reject. If the test results indicate that this person doesn't have dengue, then no problem. Then it's rejected. Same thing here. You take 20 programmer's salary
And before that, you make these two assumptions. You make assumptions. But first assumption is that the first variable, what that the experience has an impact, significant impact on what? Computer programming side. Number two, the aptitude mark has a significant impact on the computer programming side. Okay. Adiyak kita reaction ni lah tahu. Baik. Okay. So that's what it means. So you do test. Then what you do is you take the data, you put that to the computer, and you use data, and you run the regression test. And here it indicates both are significant. In that case, what you can say, these hypotheses are confirmed. Right? So you can take down testable assumptions. You have two testable assumptions, you have two independent variables. So you can say next, in the next slide, you can say, think the equivalent for p value for probability value. Of the coefficient of the experience of the coefficient of the experience variable is less than 0.1. Decompose that. So the first hypothesis H1 is support. Right? Support. It's confirmed. Support. We say either supported or rejected. We don't say accepted. We don't say hypothesis are accepted. We say supported or rejected. Right. So what's the second one? We can write the same thing. Again, it's the same thing for the next hypothesis. What's our conclusion? That also, since the sequential p-value probability value of the coefficient of the marks variable, the score variable, is less than 0.05, H2 is also solved. So finally, we can say both the experience and the marks. So, significant predictor of the salaries of computer program. Right? We will say this. Both the experience and the marks are significant predictors of the salaries of computer. What's your recommendation? Therefore, recommendation. To increase salaries is recommended. To increase their what experience marks, to increase marks, you have to increase knowledge. Where I go? Give you recommendations for significant predictors. Significant predictors. If there's some insignificant variable which was above 0.05, you don't use this recommendation. No point giving for insignificant variable. Recommendation to increase salaries. It is recommended to increase their experience and knowledge. By increasing knowledge, they will increase their aptitude test mark. Marks are knowledge. Increase the experience, increase the mark. Then what you can do? You can increase their effect. So here what you have to understand is you give recommendations for significant predictors. Is that clear? Galle with it. So you develop hypothesis and you test them. Testable hypothesis. Testing hypothesis are testable. So you can see there are two hypotheses, H1 and H2, and you tested them as a doctor tested whether there is a particular illness or not. Right? Doctor will have a hypothesis. And to confirm that, the auditor also do the same thing. Right? Now, if you are an auditor, do you have a hypothesis? Yes. What's the hypothesis? You assume what? The financial statements are what? Full of errors and fraud. Is that what you assume? You assume the management are set of fraudsters. Is that what you assume? I think what I assume? You assume that this organization, the director board and the managers are set of what? Hardcore criminals. Is that what you assume? No. The auditing standards as well as certain court cases indicate that the auditor should approach a client in an open mind. And there is a famous case called what? London Cotton Mill case, and the Lord, right, the judge of that case was telling that auditors are not bloodhounds, but other cases, they were landmark cases, they are auditing well, auditors are not bloodhounds, but watchdogs. We're going to go here again. That's how we're going to go look here again. Tadabalante, Murabalante, England, take the single and English is huge. So the Lord, right, was telling that Lord is the judge. He was telling that the auditors are watchdogs, not bloodhounds. Auditors like again, they was doing that. The bloodhound and a watchdog are two different things. So you have to approach an audit in what? In an open mind. You have to assume what? Their assumption is that there is no fraud, as well as errors. Then you do the test. You do the audit testing, and then whether you confirm that or you can reject that. And based on that, you are going to give your opinion. So that's what you do in any test. First, you should have an assumption. Here we call that what? These assumptions are what I call hypothesis. If you have more than one hypothesis, then that's we call hypothesis, SES. If you have only one hypothesis, we call it what? Hypothesis, SIS. SES, plural, SIS. Right? Right. So, you confirm or you reject. Here, our test indicates should be, right? It should be confirmed, not supported or confirmed, because both are significant. Good. So salary as well as the experience as well as the marks, the aptitude marks are significant predictors of what? That's how it is. Right. Now let me go a little bit beyond that. Okay. So you have now tested your hypothesis. You did the test and you created the hypothesis. Very good. Now let's go a little bit beyond. Let's go again back to our preparation of. Now you confirmed or you supported or you rejected your hypothesis. That's great. Now what shall do is, now we'll see what do you mean by this 1.4 and 0.25. What's that? What are they mean? Those are called what? The coefficients. Also we use the term as what? Slopes. Look at our slope. Y equals a plus dx or alpha plus beta x. Beta is this. And remember, alpha known as beta x. I was telling you. Y equals alpha plus beta x. This is beta slope. So if I ask you to write now the equation, can you write the equation? You can. How can you write the equation? By looking at this, now you will be able to write the equation. So let me write it for you. How to write the equation? Salary equal alpha plus, that's the intercept. Alpha is the intercept. So you can say beta 0. Okay. Then experience, now you have the what? You have the slope. So you can write down 1.4 experience. And you remember the equation, what was that? Y equals alpha plus beta x. Beta is the slope. Alpha is the intercept. Plus, since I don't have space there, I'm going to write it out here. Plus 0.251 is the equation that I could write. Salary equals alpha plus 1 point. So I have that for you. I'll show you that. Yeah. So you can see here, this up.
So you know the alpha value also. What's the alpha value? What's the alpha value? Where is the regression? Alpha का value का हमने क्या किया? So if you go here, the alpha value is also given, not there. देखा नहीं है? What's the alpha? 3.174. Alpha value is also given. Alpha is into it. 3.17. Plus 1.404 experience and that's it. So you can see I have given that here as well. I have given that 3.174 plus 1.40 for experience, 0.251. This is the equation finally derived out of the equation. Is that clear? So what it means is you can now predict the salary. Please write down this equation. The equation is clear. So you can write down the final regression model and write down the model. The final regression model. Final regression model. Final regression model is 3.174 plus 1.404 experience plus 0.251 mark. Okay. Right. Now let's do a prediction. Did you take it up? Okay. Predict. Please take down. Question. What is the question after? Question. Question. Predict a computer programmer's salary. Predict a computer programmer's salary. Predict a computer programmer's salary. Who is having 10 years of experience? Predict a computer programmer's salary. Who is having 10 years of experience? Years of experience and who had got 50 marks, who had got 50 marks in the aptitude test. Using the above regression model. Using the above regression model. Using the above regression model. Right? Can we do that? ඒක අපි දැන් මොකද දැන් error එකක් කොහොමද දැන් තියෙනවා ඒක කරන්න දෙයක් නැහැ. ඒක fail. So we go very good for except for slope here. Slope. So where's the slope? For the slope with the error. Error is there. Can't help. But anything after we cannot factor that in because we don't know the value. But we know that 17% is accounted by epsilon. Why? 17% is extraordinarily difficult. Because this model could only explain 83.42%. That means 17 of the remaining, explanation is done by some other variables not considered. That's only what we could say. We cannot factor that in. Right. Good question. So do the prediction. Yes. Very easy. Now it's how the experience are 10. Substitute 10. 1.404 into 10. Then 0.251
into 50. Then you will get the salary. Yes. So let's do the computation. That is the computation. Oh, it's fine. So what I'm going to do is I'm now going to go to my beloved Excel. In the Excel, where they are. Make a copy and go copy this and go to my beloved Excel. And I will paste this. I'm going to enlarge it. It looks like this. 3.174 equal sign 1 into what? Today, 10 years experience. That is the So why I multiply by 10? Because 1.404 is the experience part coefficient. And 10 years plus 0.251 into what? What's the marks that percent got? 50. What's the salary? So 3.174 is the intercept. So this is the computation. Right. Hit enter. You get the user. Right now. $29.764. Is that what you thought? But this is in thousands. Can remember, computer programmer salary was given in thousands. So this should be expressed in thousands. That means what? $29,764. Write it like that. 29.764 kilodollar. It is a dollar for India. $29,764. That's the answer. Right? So these are the values are given. The salary is given in thousands. Right? Exactly. So this is how you do a prediction. I told you that today you will be doing a prediction and these predictions. Now, can you predict? Now, you don't need to do that. Let's say a computer programmer who had 20 years of experience and 70 marks for the aptitude test. Can you predict the computer programmer salary? Yes. Just substitute it because now you know the slope and then right. Exactly. Now let me take you even more deeper. When you learn study things, you have to go deeper, deeper, and deeper. Right. Now let's go back. So the answer is not 29.764, it's $29,764. Same thing, but again in thousands. I think you can remember. This was given. You saw that the computer program is in thousands. So here the values are in thousands. 24 is what? 24,000. Now let's again go back. Again, let's go and see the equation. This is the equation. This is the equation. Now I will ask you to interpret each element. I'll help you to interpret each element. Take a something. What is 3.174? That's the intercept. What does it mean? It means when all of the independent variables are zero, what the computer programmer salary will be getting. That means when a computer programmer has zero experience, zero marks, still what's the salary that person should get? Let's say a computer programmer just joined the organization. right? That person doesn't have any experience. That person has not done the aptitude test. So no experience, 0 marks. But still that person will have to be given a salary. What's the value of that salary? What's the value of that salary? 3.174 translated in thousand is $3,174. So that could be treated as what? The basic salary. Even if you have 0 experience, even if you have 0 marks, still you are going to get what? 3.174. Why I'm saying that? Substitute what? Experience 0. 1.404 into 0 is 0. Then 4, 0. 0.251 into 0 is 0. So what remains only what? It's 3.174. That means a computer program who is having 0 experience, 0 marks, still gets how much? 3.174. It's like beggars are eating rice. Income and rice consumption. We understood if even if income is 0, still there's rice consumption. Right? Because they beg and eat, they rob and eat, they steal and eat like politicians. Oh. That's the evidence here. So likewise, you have to understand what the intercept. Intercept means when all other independent variables are 0, what the independent variables. Is that it? You have to understand these things, internalize these things. At the exam, you'll be asked these things to interpret. Right, next thing. How can we explain 1.404? I told that's the slope, coefficient, slope. What does it mean? What it means, when the experience goes up by 1 year, what will be the increment in salary? Experience එක අවුරුද්දකින් වැඩි වුණොත් salary එකකින් වැඩි වෙයිද කියන එක ඔක්කොම. Hey, වැඩි වෙයිද? Because there's a positive sign before. It's plus 4.1.40. So what it means is, if the computer programmer's salary, if the computer programmer's experience goes up by 1 year, because the experience is counted in years, if it goes up by 1 year, what will be the increment in salary? How much is that? 1.404, that comes to 1,404. So what it says is, if the computer programmer's salary goes up by 1 year, their experience goes, sorry, if the computer programmer's experience goes up by 1 year, their salary goes up by 1,404 dollars. That's how we interpret that question. Let's come to the next one. Then among you, can we interpret 0.251? What did the game says? Go back. What it shows? If the computer programmer's marks for the aptitude test goes up by 1 mark, have the same account. Taking factor 1 dependent way. If the computer programmer's marks for the aptitude test goes up by 1 mark, the salary goes up by how much? Again, it goes up by because the positive sign. 251. Write down these things. When experience goes up by 1 year, the salary goes up by $1,404. When marks goes up by 1 mark, those marks are taken by marks, of course, right? It goes up by $251. So you should be able to interpret the coefficients, the intercept, and the curve. The experience goes up by 1 year. Experience goes up by 1 year of a computer programmer. The salary goes up by $1,404. That's how we interpret 1.404. Then the next one is, if the computer programmer's aptitude mark, if the computer programmer's aptitude mark goes up by 1 mark, the computer programmer's aptitude test marks goes up by 1 mark, the salary goes up by $251. $251. $251. Okay. Understood. So, right. These equation. Okay, let me again summarize what we did. I told you, you perform regression analysis for two things. Remind me what are the high regression analysis correct? Deliver correct. To achieve two things, we do a regression. What are the first one? To do predictions. Number two, to look at what are the significant variables. Now we have got the results. Have you achieved both? Prediction correct? Did you do a prediction? Prediction 10 years experience, 50 marks skill, then predict that. You predict it. Right. Now, if you want to predict a computer programmer who has 20 years of experience and 70 marks, can you predict the salary? So you yourself did your first prediction in your life. From evaluation. That's how you make predictive models. Do a regression, get past data, and do a regression, calculate the coefficient as well as the intercept, and do the prediction. But you need to have past data. But there's no guarantee that the past patterns will repeat. But who knows? But at least they're saying in English, history repeats. History repeats. So people do again and again the same foolish thing again. Particularly choosing politicians. So I hope people did the correct choice and wouldn't do again a wrong choice. Let's see. Then second one, so it was prediction. Number two is what? Looking at what are the significant variables. Did you identify what to look at? Very expensive. Okay. Right. The next one is the next thing what we want to do under regression is what? To look at what are the significant predictors, significant variables. Did you understand the significant variables? Yes. Here we got two independent variables. What are two independent variables? Experience and marks. Api independent variables like experience and marks. Do we know what are significant? Yes. Both indicators they are significant. No. Both are significant variables. There's no anything. So have we achieved the both objectives of doing a regression analysis? Indeed, yes. Okay. At the moment, we have why? Why we were able to do everything within this short time? Because of what? State. Did I teach you what's the regression formula? Behind this, there's a huge formula. Did I teach that? No. It was taught to you. I did not teach it because it was already taught to you in your first year and maybe in your A-levels to teach that. Using pencils and pens, you were doing it. Otherwise, what a time waste. What you need to do is, once the result comes, to get proper data, run the analysis, once the result comes, to interpret it out. That's what we did. So, right. Then once the regression result comes, what's the first thing we looked at? Okay, what's the first thing we looked at? The R square number we actually R square. Yes, we discussed about R square. Right? Can you remember? What's R square? It's the expressed power of the independent variables over the dependent variable. How much the independent variables explain the dependent variable? We understood higher, better. I could at least have a 50% of expressed power. Here the value was how much? Around 83%. So what was the interpretation? 83% of the variation of the dependent variable, which is the salary, is explained by the two selected independent variables. We have what? Experience and the mark knowledge. Right? Marks is a proxy for knowledge. We took a proxy variable there. Right. Then number two. Then we went to what? After that, we checked the F test. On F test, we looked at particularly what? F value and the significance of the F test. On the significance of the F test, what did we check? Whether the overall model, overall equation, now you can see the overall equation over there. Whether this is significant or not. This is the overall model or the overall equation. Not individual variables, overall, whether it's okay or not. Right? What the F test indicated? The sig value, okay, the P value or the probability value indicated what? 0.0000. Is it less than 0.05? Yes. So what's our conclusion? The overall model is valid. Is it good? Yes. It's good. We are very happy to see it. If it is not, then the model seems not good. That means your predictors are not appropriate. Predictors are not appropriate. That is the second thing that you are going to look at. Third thing, you came into a table which is called as what? Coefficient table. In the coefficient table, first thing we looked at is what? Whether the independent variables are significant or not. How did we check that? By looking at the P values. By checking the sig values, significant value of the P value, probability. Here in both cases, both had less than 0.05 sig values. The P values were less than 0.05. So what was our conclusion? Both were significant predictors. Accordingly, we also try to link that with the hypothesis. How many hypotheses that we developed? Two hypotheses for two independent variables. What was the hypothesis? H1. What was H1? The experience has a significant impact on self. Look at the term what we use. Impact. We developed a similar hypothesis for correlation analysis. What was the term there we used? I did not use impact. I used what? These are the group. These are the not taken asset. Relation. Or the associate. Today I am using the term impact. Therefore, please, students, understand, to see the association, you do a correlation analysis. To see the impact, you do what? Regression. These are two different things. So I developed the hypothesis what? The experience of a computer programmer has an impact on what? Computer programming. Did it confirm? Yes. Because the individual sig value was what? For experience variable, with the coefficient table, it was less than 0.05. Can we get it? Experience, you can see the sig value is 0.000, which is less than 0.05. So, what you do? You confirm. Right? You say that there is significant impact of experience on what? The salary. So, you confirm what? H1. Hypothesis what H1 is supported or confirmed, not rejected. Plus is less than 0.05. Right. Then the marks variable. The marks variable. Is it significant? Yes. That is also significant. In that case, H2. H2, hypothesis H2 was what? There is a significant impact of what? Marks on the salary variable. He also confirms or supports that hypothesis. So that's where we confirm whether they are significant impact by developing two hypotheses. Testability. And did I stop from there? No. I took you to the second phase, the second objective, which was indicated as the first objective, but second objective is what? To do a prediction. So after getting the model, I did a prediction as well. By giving what? Predict the computer programmer's salary. If the computer programmer gets 10 years of experience, having 10 years of experience and 50 marks in the aptitude test. So did you predict it? Yes, you predicted. It was around something 29% growth. Did you get it? So you did the prediction. Did I stop from there? No. I went even deeper and I explained how to interpret the regression model. Right? So how to interpret 3.174, which is the intercept? How to interpret 3.174? It's the intercept. That means if a computer program is receiving 0, right, experience, is having 0 experience and had received 0 marks, the aptitude test, still that person is getting how much? $3,174 as his or her salary. Then I interpreted the coefficient of what? Experience. The experience coefficient is 1.404. How do you interpret that? How do you interpret it? If the experience goes up by 1 year, the salary goes up by $1,404. Because there's a positive sign here. There's a positive sign here. Take a negative na anipatharike. If the computer programmer's what? Experience goes up by 1 year, if there was negative, the salary goes down by 1,404, which is not applicable here because they are the positive sign. On the other hand, 0.25. 0.25. 2.1, let's say. How do you interpret that? What it says is, right, if the marks goes up by 1 mark of a computer programmer, the salary goes up by how much? 251. Good. Why you are making it multiplied by 1,000? Because these are expressed, the salary is expressed in 1,000. Given in the example. That's where we finish. Is it clear? Okay, that's good. So I summarized as well. Okay. Now time to do an example. So next week we'll practice this. Then the practice circle. We practice. We put this into practice, and we'll see how to practice this and how to do. And in fact, there's an example I have given. Right. Okay. Yeah. I'll put the example after. I'll use a practice example. Right. You can do it within 10 minutes and we'll interpret it. Same example I had, if it expand. Right. You go to the LMS and there is data section for expanded salary 200. There are 200 negative. If any, this is a theorem, so you can theorem. T2 Excel, it's in Excel file. Please use this file to do again a revision. I'll you 10 minutes. And then answer these questions. What's the explanatory part? What is the overall significance of the model? Right? Then comment on the individual significances. Look at the function table. Provide recommendations. And then do a prediction. And we'll do that, please. Right. Then what I call like you can do it pairs. Or randomly connect here like the current now. Right, how to do that? Okay. So then under LMS. Go first to the LMS and go to
this particular file, data session 4, expanded salary, 220 observations. Now in this data set, how many observations are there? Only 20 observations. The negative this is. Now using this file, can you do a similar? I take a what? Experience against score criteria. So what it says is in this example, the independent variables are again experience and score, and the dependent variables salary. Can you get together and do a regression using the specs? One thing what you have to do, download the Excel file and import that Excel file. Import the contents what? State. Make Excel worthy. Elements data open karan hai. You have to import the data. Then do what? Do the and give the answer. And then we learn that the values of that. Ready? Take 10 minutes and look. First download that Excel file. Then import the contents to data. Then perform the regression and ask those questions. Hello. This is work together. Then करना ये बड़ा है. Look at how we are going to do the thing. First download that file. Download करना तो मैं file is self. Data region code. Okay, go to the elements and download them. Okay. Right. Then what you do is please import that file. Go to file. Then import Excel. You cannot open them unless. Then locate the Excel file. It might be download folder. Go into the download folder. It's my data session 4. I will to open that. So shall I press OK? OK, Karan? OK, Karan? Good. Avatar Karan होगा तो मैं ठीक है then only the variable names become variable names. If not, it also will be taken as an object, which I told you long back. So make sure you put this tick at the value over there. Then now press OK. So make sure you select the file and tick this. You press OK. Right? Then the data comes in. The next is what I told on the regression. But before that, best practice is what? View the file. So I will go to browse. Yes, now you can see there are 220 observations. That's good. Now run the regression. How to run the regression? What are the good one? Statistics. Medium models are related. Go to linear regression. Again, what's the dependent variable? Salary and experience and scope. The independent variables are experience and scope. You press OK. Now you got here number of observations of 220. Earlier it was 21. And yes, you look at the R square. R square is also almost the same. 83.4%. What's that? The explanatory power of the independent variable. Then what about the model significance? Is the overall model significant? Is the overall model significant? Yes. The probability value is 0.000, is well below 0.05. The model is significant on an overall. Right. So we answered those questions. So these are the questions that are following question again. What is the explanatory power of the model? 83.42%. What is the overall model significance of the model? It's significant. Then comment on the individual significance of the independent variable. Then you asked now comment on the individual significance. What you have checked? Coefficient table. Diagram coefficient table. Look at the coefficient table. Here you can go to the coefficient table. This what is called the coefficient table. This coefficient table you can see the individual significance for experience and for argument. Are they significant? Yes. Fine. Both here you can see the sig values, the p values, or the probability values are less than 0.05. No issue, no problem. So there's significant. So comment we did, it's significant. Then provide recommendation to increase the salary that a computer programmer should do. Then to provide recommendation. Give recommendations only for significant variables. Don't give recommendations if it is not significant. Here they have two independent variables. What are those? Experience and marks. So can we give recommendations on both? Yes. Because both are significant. In that case, if the computer program wants to increase the salary, what kind of the first recommendation would you have? Increase your experience. You will get more salary. That's number one. Number two, increase your knowledge and the aptitude test marks. That will increase your salary. Right. Those are the two recommendations. Then prediction. How can you do a prediction? Yes, indeed. For a computer programmer who has 30 years of experience and 70 marks in the aptitude test, what would be the predicted salary? So what you need to do is you go back to and write down the model. The model is salary equals 3.174 plus 1.404, almost same, and 251. The same thing. And then substitute those two values. What are the values? 30 years and 70 marks. 30 years. And 70 marks. 30 years. 1.404, let's say, 30 years. And 70 marks. So, is this what you got? 52 people, 864? To do it home and see whether you get this. That's what 30 years and 70 marks. Almost it should be something like that. 62,864 shirts. Right. So we did a small exercise as well. Please do it at home and come ready because next week we'll do group exercise. So, in correlation and action, what? And you know, painting the gut. Right. So with that, then we take attendance. Attendance come in. We'll get attendance. Okay, so with that, then thank you very much. So revise the content, correlation and regression analysis, and next week we'll have a assessment, a group assessment. Be ready for it. Awesome. They do not fight. I'm going to Thank you very much for online students as well as teachers and online students. Thank you very much. We'll meet next week.